This mechanism is going to be the bromination of benzene. So this falls under electrophilic aromatic substitution, and it's one of a lot of different reactions you can do to remove a hydrogen and replace with something else on a benzene ring. So overall, the reaction conditions, you add bromine and iron tribromide, and you end up with a brominated product. There's a little bit of a shortcut for drawing this mechanism where if you're in class with me, I think that's good and we'll use that. So what's happening is bromine on its own can't react well with benzene. It's not reactive enough. We need to activate it to make it a better electrophile. So bromine needs iron tribromide to make it more reactive. And so what's going on there is the bromine Br2 is actually reacting with the FeBr3, so it's acting like a Lewis acid here. So we make this impressive looking iron bromine complex, and there's two ways to draw the mechanism. One, you can just take benzene reacting with this, where the pi bonds will come in, attach to a bromine, and break off, and you get FeBr4. I'm going to draw my mechanisms doing this step already, so separate these two to make FeBr4 minus and Br plus, and then just use Br plus as my electrophile in the reaction. It's a little bit of a shortcut, but it works well in this case and helps clean up the mechanism a little bit. So ultimately, bromine's not a good enough electrophile to react with benzene, so we need iron tribromide in there to complex with it to make it more electrophilic. So this bromine acts like Br plus in the reaction, and then it just does the normal mechanism that we'd expect. So our pi electrons will come in and attach to the Br plus. All right, so acting like a nucleophile, reacting with our electrophile. Right. These pi electrons are gone. I'm going to draw in the two hydrogens that were always there. All right. One of the carbons, doesn't matter which one in this case, gets a bromine. The other one ends with a positive charge. So we've got an intermediate now, and you have the carbocation that's stabilized by resonance, but overall destabilized. And in this step, then we need to eliminate a hydrogen and bring it back to the aromatic ring. And key is to always take the hydrogen adjacent to the positive charge, not on the same atom. And then you end up with the brominated aromatic ring there. So Br plus acts as the nucleophile, Br minus as the base. We end up with the substituted aromatic ring there.